Okay, Assalamualaikum. Today we're going to move to a new part of our class, okay, which is assembly language. So this will be the first lecture, an introduction to assembly language. Okay, so this is an overview what we need to learn, what we want to learn assembly language. Okay, so basically we're going to learn what is assembly language, okay, why is assembly language is important, what is machine instruction, what is a assembly language instruction, okay, the relation with Intel architecture, and also some hands-on activity. Okay, so what is assembly language? Okay, so assembly language is basically, okay, it's in between. Okay, we have high level language and we have low level language. So high level language is basically the one we learn in class, such as C++ and Java. While low level language, there are two low level language. The lowest low level language is machine language, which consists of 0 and 1, a binary number. So before that, there is an intermediate language, okay, that computer can understand easily, and also human can understand quite easily, not that easily. Okay, that is called assembly language. That means we have high level language and we have low level language. High level language is the programming language, and the low level language, okay, so consists of first assembly language, and the lowest will be machine language. Okay, so moving on. Okay, so assembly language, you assembler, okay, assembler, a program that convert or translates source code program into a machine language. Okay, so that's what assembler means. Okay, so why it is important to learn assembly language? So other than for the opportunity to know about furthermore about how PC operate, okay, it's also allow us to enable control to access to specific hardware feature. Okay. So machine instruction is basically the binary code, a sequence of 0 and 1. Okay. So it is very meaningful to computer, but it's just a number for us. So you need to be able to translate. So that's for example at the bottom there, if you can see 0000100. Okay. So for us it may be mean nothing, but for computer it means add a number to the uh, accumulator low register. Okay, 1010 0011 might mean move the AX register to another register. Okay, so machine instruction, okay, or machine language is important to machine, but it's hard for us to understand. So register are high-speed storage location inside the CPU, which are used by nearly every instruction. So as we can recall, inside CPU there is a register, okay, and after register will be connected to cache. There are three levels of cache. Then only it will connect to the RAM. Then only it will connect to our secondary storage. Okay, they are identified by tools such as, okay, accumulator high, accumulator low, or accumulator and so on. So we will discuss this further later. Okay, we refer to machine instruction using hex number because they take up less writing space. So basically, in assembly language, the instruction is in binary, but to understand binary is quite hard and it's going to consume a lot of time and there might be error. So to make it easy for us, instead of using binary, we will use a lot of hex number in assembly language. So assembly language instruction is mnemonic. That means it's short form. Okay, like move instruction, instead of MOVE, just use MOV. Okay, and directive, okay, we will use DB. Okay, define byte to create a bytecode. So an instruction may contain 0, 1, or 2 operand. Okay, that means after the instruction like move, okay, there can be 2 operand, a x, comma, 1, 2, 3. Okay, we will see the example later. Okay. So Intel architecture. Okay, so since we are here already, so why do we try to see what does it mean by there are 14 internal registers in Intel. Okay, so we try to emulate empty instruction. Okay, so we can count here. There are, okay, how many is here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9, uh, 9, 9 plus 3. So 9 plus 3 equal to 13. Okay. So 13 available register. And the fourth and the 14th one will be the flag. Okay. The flag register. Okay. So they are grouped into several. Okay. So for every this is the what call that? Okay, let's discuss this one later. Let's move on. Okay, so let's move on here. Okay, the next slide. Okay, register as previously discussed. There are what you call it? There are 14 of. Okay, so here you can see 13, and here the flag, the whole flag. Okay, is the 14. Okay, so we have general purpose register AX until BX. So this is AX. Okay, until DX, and then we have special purpose register. Okay, SP, BP, SI, and DI, and we have segment register CS, what is ES, ES, and SS. And the next one, okay, we have, oh, here, we have IP, instruction pointer, previously known as program counter. So instruction pointer here. So this will show where our program will start. Okay. And then we have status flag. Okay, the whole 8 here. Okay, that's good. The next one. Moving on. Okay, so what is AX? Okay, so AX, you can see here, AX stand for, is it? Accumulator. Okay, so accumulator register. It mainly used for what do you call that? The arithmetic, for the arithmetic control. That means when you add something, usually you store in AX. When you divide something, you must store in AX. Okay, multiply or divide something, you must store in AX. Only AX will affect. Okay, and then we have base. Okay, so base is used for indirect addressing. Okay, where is it? Okay, base address. Okay. And then we have counter register, okay, or count register, counter, and then we have data register. So counter usually we use when we use looping, okay, or shifting or rotating. Okay. And then we have data register where we normally store our overflow value. Okay. And then for special purpose register, we have stack pointer. Stack pointer, whole address of top of the current stack. Okay. And then we have base pointer. Okay. And then we have source index. Okay. Source index. And then we have index register. Is it? Index register. DI. Okay. Destination index register. Okay. And then we have segment register, which is CS code segment. Okay. This is the code segment 0, 1, 0, 0. Okay. Our stack, what we call this, instruction pointer start at 0, 0, 0. Okay. So the next one is the data segment register. Okay. So where we will store our data. So data segment start at 0, 1, 0, 0, save. Okay. And then extra segment register, ES. At the moment, ES is the same one. And then segment register, okay, for the selector. So SS still the same value. So other value is not used currently. The BP, the SI, and the TI. Okay. So flag, we have 8 flag. Okay. So 8 flag. Okay, but you can see 8 flag here. Okay. So you can see 8 flag here, but we're going to only cover 6 of it. Okay, we're going to cover carry flag, zero flag, sign flag, uh, overflow flag, okay, and then priority flag and auxiliary. So we're not going to cover interrupt enable flag and also direction flag. Okay. So this is the short form for all the flag. You can see that it has the similar symbol. Okay. And then next one, what else? So instruction pointer. Previously in our lecture, we know it as program counter. Okay. So instruction pointer give the starting address. So we will start our program here at 000. And then debug. Okay. So debug, basically debug. Okay. In the old Windows system, when you go to your command prompt, okay, when you go to command prompt, you can start your assembly. You can start managing your assembly language by typing debug. Go to debug. But now it's not there anymore. Okay, so since it's not there, that's why we will use emulator. Okay. So we can skip this one. So this is the example of the old command. So basically this is similar to Windows command. Okay. And then let's try something. Okay. So let's copy this one, this all instruction here. Okay. Let's try this one. Let's see what happens. Okay. So let's put a comment at the back. Okay. Let's put a comment there. It's simpler. Okay. Comment there. Okay. Let's put a comment here. Let's just comment the back part. Okay. Comment there. Here. Comment there. Here. And okay. Things a little bit organized. Okay. Let's back. So let's try to emulate an error. Okay. So if you can see that here, we have an error here. Okay. So if copy this one, because this example is given with the address. Okay. But the address of instruction in our assembly language is here. It's already there. Okay. So what we need to do here is we need to delete this one. So let's delete the front part. Okay. And here. Okay, nice. Okay, now try to emulate again. Okay, now we can see everything is there. So it's not starting yet. Okay. So we will view make it a habit to view your flag. Okay. So now let's try to run it. So let's run a single step. Okay. So we are not starting yet. So the first command will be move the value of 0, 1, 2, 3. We forgot the H here. Okay, let's try. So if you move 0, 1, 2, 3, that means you are moving decimal number of 0, 1, 2, 3. So it needs to be converted into hex first. So the value might change. Okay, so it will be 7B. 123 in decimal means 7B in hex. Okay, 25 in decimal means okay, it add up. Okay. So to correct this, okay, correct this one in our simulate and our source code, we can do is we can put H here. Okay, let's put H there. Let's try to emulate. Okay, nicely. Let's view our flag. Okay. I think we try to do it formatting. Okay. So nothing here. Okay, let's try to view that too. Let's move. First, we move the value of 0123 hex, okay, into AX. So 01 will go to AH and the 23 will go to the lower part, okay, the AL. Okay, and then okay, we move, we add it. Okay, the next instruction say add AX with the value of 5. Okay, so if we look at the previous value 0, 1, 2, 3. So 2, 3 add with 2, 5 will make 4, 8. So we get 0, 1, 4, 8 at AX. Okay, and then here we're going to move the value of AX to BX. So that's mean BX going to get the same value as AX. Okay, and then add AX with BX. So we're going to add AX with BX and store it at BX. That means BX going to double the value. Okay. Okay, good. And then move value of BX to CX. So that means CX going to get the value same with BX. Okay. And then we're going to subtract later. Subtract AX, CX with AX and store at CX. That means 0290 minus 0148 store back at CX. Okay, that means CX going to get 0148. Okay, after subtraction. And then we're going to subtract AX with AX. So AX minus itself, so the value going to be 0. Okay, the last one is say jump to 100. So if we jump to 100, now we are at line, our instruction pointer is at 10. Okay, so line number 10, line 10, okay, 10. So if we say we're going to jump to 100, that means it's going to jump to, okay, 64, line number 64 in hex. Okay, so that is the first mistake we did. Okay, so let's try to close this one. Let's correct this one first. Okay, put an H, the H there, no problem. Let's try to emulate again. Okay, view our flag. Okay, so let's try to move. Okay, ready? So we're going to jump to address 100 in hex. Okay, so IP instruction pointer will change to 0100, and we will observe here it will be 01100. Okay, try. See, so it's going to jump here, but it's still wrong. The idea is to make this program an infinity loop program. So we try to reload again. Okay, so we can see that our address start with 0. Look at the instruction pointer. Okay, our address start with 0. So what we can do here is we change our jump to 0. Okay, so that our program will be an infinite loop program. So let's try to do this one. Okay, first one, move 0123 to AX. Okay, so A high going to get 01, A low going to get 23, and then add AX with the value of 25. Okay, so the change is going to happen only at A low. Okay, 23 add with 25 going to be 48. Okay, and then move AX to BX. So 0148 will be copied to BX. That's one. Add BX with AX to add BX. That's mean this value. Okay, these two value. Okay, the BX value add with AX values to add BX. So BX going to increase by double, and then move BX to CX. That means CX going to get the same value of with BX, and then subtract CX with AX. So CX minus AX. So we're going to reduce the value of CX by half. Okay, then subtract AX with AX. That means AX minus AX, we're going to get 0. And then jump back to 0. That means we're going to move back to the beginning of our program. Jump. Okay, so this is an example of infinity loop program. Okay, so we can simply run this program automatically. So it's going to continue non-stop. Okay, see? So now we have managed to develop an infinite loop program. Okay, so hopefully you can try to understand how assembly language work. Okay, so I think that's all for introduction for today. Okay, so remember that as previously discussed, okay, in assembly language, okay, in Intel architecture, there are 14 internal register. Okay, 13 you can see here. The 14 is the flag itself. Okay, so the general purpose register consists of AX, BX, CX, and DX. Each register consists of the high part and the low part of itself. We also have 4 special purpose register, 4 segment register, and 1 instruction pointer, or in the previous lecture is known as program counter. And last but not least, we also need to observe our flag as the 14th register. So I think that's all for today for this session. So Assalamualaikum. See you next lecture. Thank you.